Hey everybody, what you see here is a part of a larger video. It's a clip from a larger video on vertical asymptotes. You're going to see kind of a walkthrough of being able to determine the vertical asymptote, as well as 2 limit checks to determine nature of the curve. We'll finish it off with tying all that stuff together to give a partial sketch. So I hope this one helps. Good luck. So take a look at your screen now, and I've given you a big, ugly function. And what I want you to do is to be able to go through and find all the asymptotes for that curve. And once we do, then we're going to make a partial sketch again. So first thing we look to do is to see if we can simplify that. And at the very least, we can see that that function is fully simplified. Like the only way I could reduce that fraction would be to divide out a common factor. And since on top I have an x squared, I don't have a common factor of x on the bottom. So that is fully simplified. Okay, so the next thing I'm going on the hunt for, I'm looking for my vertical asymptotes. That's what the problem says. Find all vertical asymptotes. So as I go through to find those vertical asymptotes, I need to see what makes my denominator equal to 0. So in that whole fraction, all I really care about is this. And therefore, I'm going to go on the hunt just for that bottom. So to find my vertical asymptotes, I am going to set my bottom, that's a cubed, equal to 0, and then solve. So I have 4 terms. I really like the look of it because I can common factor out an x squared from the first, a -4 from the end, and pretty quickly I see that that cubic is going to factor by grouping. So in this instance then, I could get to this line, and some people would really like to put this line down. It's not needed for the vertical asymptotes, but it may make things a little easier for me because I could actually collect my x minus 2's. We still see anyway that I have at x equals 2 or -2, those end up being my x values that make my bottom 0. Now, in terms of how would you express that? For us to solve an equation, we would then normally just say, well, x equals plus or minus 2. The problem becomes you're actually writing vertical asymptotes. And so since each of them represent lines, they actually represent different lines. So make sure that you would then state that we have an x equals -2 vertical asymptote and an x equals 2 vertical asymptote. There's no such thing as x equals plus or minus 2 vertical asymptote. Okay, now that we have those as our vertical asymptotes, it's time to find our nature. And so for that, we're going to jump in and we're going to play around with some limits. Okay, here we go. So what you'll see up on the top of your screen is our 2 versions of what we could go through and use for that f of x function. Now, one of the things that I want to make sure we're good with is clearly you can use either version to test your limit. However, because what we're examining is what makes the denominator 0, and then on either side of it, a lot of people tend to like the blue to be able to evaluate the limit, the factored form of that denominator, because then you can just deal with your signs. If you ended up dealing with the original in the green, well, now as you go through, you're going to have to calculate a bunch of stuff on the bottom. So my recommendation to you is, if you've done all that work to factor the denominator, use the factored form, especially if you're pretty confident with it. So we're going to jump in and we're going to deal with our limits. What I'm going to address first is my vertical asymptote at x equals -2. I'm going to deal with the most left asymptote at the beginning. And then just like before, I can work my way left to right, and then I can transfer all my information to my graph. Okay, well, I'm going to deal with my left side for that function. And it's a pretty big equation to lump in there. Okay, now to evaluate that limit, I need to imagine that x is so close to -2, I can treat it like it's -2. So I'm going to sub in -2. And you'll notice that I made the substitution into my brackets and then simplified anything that was easy. Now, I still have further simplifying I can do. So x is so close to -2, I treat it like it's -2. Well, on my denominator, 16 times 0 is 0. So there is all my work where it was so close to -2, I treated it like it was -2. And now I have to go back and remember it's not really -2. So since I'm approaching from the left, it's really a little bit to the left of -2, and that would be a bigger negative. I don't care about any directional symbols on the 4 or the 16. I care about it on my 0. And so that last factor of x plus 2 is what gave me my 0 when I subbed in -2. So if I'm instead going to sub in a little bit to the left of -2, then I'm subbing in a bigger negative. And so if I then take a bigger negative and I add 2 to it, I will still be stuck with a negative value. Now, that's a little difficult to see, so I'm just going to go ahead and erase that to make it pretty obvious. There is my negative bit, my -0. My 0 negative, I should say. Okay, well then what does that mean for my denominator now? Well, when I take that positive 16 and I multiply it by that really small negative bit, that 0 negative, then it's still going to give me a really small negative value on the denominator. And now I can calculate that. A positive divided by a negative is a negative, and 4 divided by a really small number that's always getting smaller is going to become huge and keep getting bigger. There's my infinity. Okay, now we can go to the right side of that asymptote. So as x approaches -2, but from the right side. Now, are we okay if we want to start shortening up some of this notation and not having to write out that full equation again? Remember, every limit needs a function, but I can just call it f of x, like that is the name of the function. So if you want to save some time from rewriting all that out, feel free. Okay, now I'm going to look back to my blue form to make sure that I'm subbing in. So I'm subbing in so close to -2, I can treat it like it's -2. And I should get the same thing if I made my substitution correctly. But this time I'm subbing in a little bit to the right of -2. So numbers a little bit to the right of -2 are smaller negatives. So when I look back at that factor that gave me 0, if I'm going to sub in a smaller negative for x, then when I add 2 to it, that's going to be enough to change it to a positive value. So I have a positive bit on my denominator. Okay, well now I can calculate. Well, I have my 4 over 16 times 0 is 0, but it was really a positive 16 times a positive little bit. So that denominator would still be a positive bit. And therefore, a positive divided by a positive and 4 divided by a number that's always getting smaller gives me something huge. So there's the nature of the curve for us to be able to walk our way through on a little bit more of an uglier function. Okay, what I want you to do is I want you to work your way through dealing with the nature as x approaches 2. That is, we're going to deal with the nature of the curve for our other vertical asymptote. I want you to try it on your own and we'll see if we match up. So go ahead and pause the video now. Okay, and so we're back. So we're going to work our way through evaluating that other limit. So I'm going to address my limit as x approaches 2 from the left, 4, and I'm going to write in the equation of that function again. And there we go. Okay, I'm imagining subbing in values so close to 2, I can treat it like it's 2. So on top, I get 4. And on the denominator, I'm hoping that we can get to this pretty quick. Now I can go through and I can calculate. There is me subbing in 2 for all my x's. But now I have to remember it's not equal to 2. It's a value that's approaching 2 from the left. And so I could think of it this way. If I'm approaching 2 from the left, then that's going to make a smaller value. And so in my factor that gave me my 0, if I take a smaller value and then I subtract 2 from it, then that's going to give me a negative value. The big issue, though, is that 0 negative, that negative bit, is then squared. I hope you can see why it really didn't matter. Well, now that means that my negative bit squared is going to become a positive, and so that positive times a 4 gives me a positive bit. And so if I have a positive divided by a positive, and 4 divided by a really small number that's always getting smaller, becomes huge. Now, you get a little extra practice with that, and perhaps we're even at that point now, where when you address the limit as x approaches 2 from the right side, very quickly, we could probably get to this. And my reason for it is, let's look back at that factor. Like the fact that I'm approaching 2 from the right side, or the fact that I'm approaching 2 from the left side, because I'm squaring, then no matter what sign of bit that I get inside that bracket, it's always going to be turned into a positive. And so when I evaluate that, then I can get to my 0 positive pretty quickly. And we come down to infinity. So hopefully we matched up and everything went okay. And now we're going to put everything together as a sketch. And so what you'll see on the left side of the screen, there is our information about our asymptotes. So I've listed out the properties. Now it's time to sketch them. So I'm going to match the colors that are given with the properties. So if I was to take that red asymptote, which is at x equals -2, then maybe I estimate that that is about 2 units on whatever scale I'm picturing on my x-axis. I label my asymptote as the equation of the line, and now I can put on my nature of my curve. So as I go and approach that asymptote from the left, I go to -infinity, so I'm going down. As I approach from the right side, I am going to +infinity, so going up. I then take a peek, and I have an other asymptote that would be at the same distance away. So I'm going to try to make that as proportional as possible, because that's at x equals +2. I label it with the equation of the line, not just 2, but x equals 2. And as I approach that asymptote from the left side, I'm going up. And as I approach from the right side, I am going up. So that would be the information that we would be able to sketch. And there are some things that we would be able to put together. Clearly, though, without any points like intercepts, we don't really know any specifics of the curve. But, you know, we could draw some conclusion that maybe we do something like this and we loop around. Like, I don't know, like that looks like a little bit of a parabola section on that branch of our function. And depending on my asymptotes, my intercepts, maybe I do something like that on one extreme and I do something like that on the other extreme. I don't know. I'm guessing, and I'm just trying to use some connecting ideas to come up with the green, but that would be a partial sketch. Where we go in the future is we come up with the ability to fill in the rest of that curve. So for today, if you are able to work your way through vertical asymptotes, the idea of how to find them, and then how to examine nature of the curve using limits, to then be able to connect that to what does that mean from a graphical standpoint? What does the picture look like? That's your goal for today. If we're able to do all those things, then I think you've got a great day ahead of you. Okay, jump in, play around with some practice, maybe go back and revisit some parts of this video, make sure you're good to go. Okay, good luck.